So today we are going to be talking about prism volume. So if you look at your MCAS reference sheet, it will tell you that the formula for a prism is the volume equals a big B times H. This big B means the area of the base. So that means we need to use what we were doing last week where we were figuring out the volume. We're doing that right? Yeah, we're figuring out volume of all these different shapes. We're going to be using that area to help us. It also says that for a cylinder, the volume is pi r squared times the height. Pi r squared is literally the same thing as the big B. It's just the area of a circle. So this prism, that means that's what a cylinder is, a prism. So the way you define a prism, or the way I define it to make it easier for me to figure out, is the prism is two shapes that are facing each other and connected. So it can be two squares that are facing each other and connected. It could be two circles that are facing each other and connected. Like, haha, I have a cylinder in front of me. This is a cylinder. Note the base is a circle. This is a circle, so the two bases, and then the height is what the distance between the two bases is. This is true for any type of prism. Like, this calculator here. This is also a prism. Note how the base is this rectangle on the bottom in here, and the height is the distance between the two bases. With rectangles, sometimes you can choose like, this could be the base, and then this could be the distance between the two bases. Those are all the examples I have on me on hand. But we're going to look at some examples that I drew. But as you can tell, you can see prisms everywhere in everyday life. Like, for my chocolates, for my calculator, for candles, things like that, they are all prisms. For cups that you have, and this is where volume comes in. So I have this cup right here, and I want to know how much water can I fit in it? Well, that's where volume comes into play. I can see how much I can put in there. Just like, say you're making a recipe and it calls for 12 ounces of corn from a can. Most cans are 12 to 16 ounces, and they can figure that out by volume. So we're going to do, now that I'm done talking about random real-world examples, I'm going to teach you how we can actually do it. So I already drew these out because I'm terrible at drawing these, so I had to copy them from the internet. So the first one, first we have to find our base. So our big B. So I want to see what shape is my big B. Well, if I look at this orange right here, that is my big B. So my shape is a rectangle. And if we look at our MCAS reference sheet, to find the area of a rectangle, area is length times width. So we can figure that out. So my big B here, my area or my big B, is 4 times 10, which is 40. So my big B is 40, and then my height is that distance between the two bases. So in this case, it's 12. So my volume is my big B, which is 40, times my height, which is 12, which if I use my rectangular prism of a calculator, 40 times 12 would give me 480. Note the units here are centimeters. So we were talking about squared for area. For volume, the units are always cubed. And the reason they're always cubed is because, well, here, the units are already squared. And we're multiplying more units onto it. So I have centimeters times centimeters times centimeters, which means it is centimeters cubed. So that is the volume of a rectangular prism. Well, next, we have a circular prism, or most commonly known as a cylinder. The reason being is because our big base is that circle. So our big base is a circle, where up here it tells us that the area of a circle is pi r squared. So in this case here, our area, or our big base, is pi times 8 squared. Again, I'm going to get out my rectangular prism of a calculator. I'm going to do 8 squared, which is 64, times 3.14, because that gives me pi. And that gives me my big B is 200.96. Again, I go back to my volume formula for our prism. So I have my volume is my big B, which is 200.96, times my height. Remember, height is the distance between the circles. So my circle starts here, it ends here, so that is 14. So I multiply times 14, and my volume of this cylinder is 2,813.44 inches cubed. So you can keep doing this formula over and over and over. So let's look at our next problem. Sorry, there we go. Let's look at our next. First, big B. What is the shape of our base? A triangle. And what's the area of a triangle? 1/2 base times height. So in this case, my big B is 1/2. The base of my triangle is 12. And the height of my triangle is 11. Remember, to find the height of a triangle, it is the distance from the top to the bottom at a right angle. And see how there's that little right angle there? So I can put this in my calculator to find my big B. So my big B is 66. So my volume equals my big B times my height. So the height for this one is 13. So that means I would get 4,356 watts. Meters cubed. So that means that's probably a very, very big building, but I could pack in that much water into that building, or that much soup, or that much paint, or that much of whatever liquid I wanted to. I could put that much into that building. So I want you to try the next one on your own. So find the big B, then do the volume. This one's a little tricky, so find the big B first. So, our big B here. You might have been tempted to be like, oh, it's this rectangle right here. But that rectangle isn't facing another rectangle. Therefore, it can't be the base. The bases have to face each other. So my big B here is this triangle. This triangle faces another triangle on the other side. So my big B is my triangle, which we already did up here, which is 1/2 base times height. So my big B is 1/2. My base is 15. My height is 9. So if you got this wrong, you want to put this into your calculator and see what you would get. Your big B should be, get it? Okay, sorry. 67.5. So that's my big B. Now we need to know the height, or the distance between the two triangles, to find our volume. Because our volume is our big B, which is 67.5, times the distance, which is 4. So that means my volume is 270 inches cubed. So volume is super, super easy with prisms. No matter what the prism is, you use the same exact formula. The only thing that changes is that big B. Very last one. Everyone's favorite, a trapezoid. Everyone loves trapezoids. So this is called a trapezoidal prism. Try saying that 10 times fast. Oh, tongue twister. Okay, anyway. So, our base is a trapezoid. And do you all remember what is the formula for a trapezoid? The area is 1/2 the height times base 1 plus base 2. So in this case, our big B is 1/2 the height of our trapezoid. So this is my trapezoid right here. The height of my trapezoid is right here, so it's 5, times my bases. So this is one base, which is 8, plus my second base, which is 5. That is the area of my trapezoid. So the reason I always find my big B first is so I don't get confused. Because later in the volume formula, we have that height there. But notice we have height in all these formulas as well. So by separating each thing, it helps us so we don't get confused with what's what. So you want to put that in your calculator. And you should get the big B to be 32.5. Now, last but not least, our volume. Volume is our big B, so our 32.5, so that area of the base, times the height, so the distance from base to base, which is 6. So you should get 195 meters cubed. So again, the volume of a prism, what makes it a prism is that it has those two shapes that are facing each other. So that's how you can tell if something is a prism. Next week we're going to work on pyramids, and that's a little bit different. So these are all some examples you can take with you. Honestly, it doesn't matter the shape, it doesn't matter what this prism looks like, as long as you can tell the shape of the base. So again, hope you're having a great week. I miss you all. Yeah.